Hello everyone. In this video, we'll take some of the previous things we've learned and apply them to a practical example. Again, we're in the Napo scene, and if we look at the bottom here, we have all of these branch offs for our different render passes. And the way it normally works is you'll have a PIMan object statements to set the visibility, then a render settings node, and then a render node. And this was all created manually, so you'd be copying and pasting and changing everything. What we want to do is actually create these automatically instead. Now I'm going to do something a little bit more of a simplified version than this to give you an example of what you can do, but you could build upon this most definitely. Let me just clear what's currently there, and what I'll do is I'll show you what we're working towards. So I'm going to make a PassBuilder node, and this node contains a Python button, and will have our code in it. And you click this and it's going to go through and build all of our passes for us. Now in the code, what it actually does is check under root world geo for any child locations, exclude the camera, and everything else it will create a pass for. So we have the env house, and we've got Avo, Jow, and May. You'll see that May isn't in the list, and that's because part of the code will be going through every shot and seeing what's underneath that location and adding it to the list. So if we switch to 1030, for example, 1030 has char May. So that's what we want to do. Okay, so let's try and build this then. Let's go over to the Python tab, and we'll build everything here to start off with, and once we're happy we can then make our node and put the code in here. This will just make it a lot faster for iterating. So I'm going to drag this node over here and call this node equals, and when we actually have our code, node is a reserve variable for the node that you're running the code on, but for now we're just going to grab hold of this node and add it as a variable here. Next, what we're going to do is get the root node. So root node equals node graph API get root node. And from the root node, which is going to be from here, we want to get our variables shot location. So that's get that parameter. So we'll get parameter variables dot shot. So you might not have a shot param. So for example, your scene hasn't been set up with the shot variable, so we want to warn someone that that's the case. I'm just going to do a print statement for this. Okay, if we do get the shot param, we now want to get the value param, which will be a shot param get child value. So with this shot parameter, it is one of these L ones, so it has a local default, etc. So it'll always have the group parameter of shot, and underneath it will have the value parameter, its enable parameter, and in this case it will have a options parameter which contains the list of all the options that would be inside this pop-up menu. Okay, so we want to get that, and we want to get our actual value, so we'll say current shot is equal to value param get value, because what we want to do is iterate through all of the shots, but when we're finished, set it back to the current shot. So now we need our options param, and that is going to equal our shot param get child options, and then our options is going to equal options param. And then we'll say for option in options do. So we're going to cycle through all of our different shots. And we'll say shot equals option get value. And that shouldn't be get value, it should be get children, sorry. So this would be a group parameter with child parameters of each of the options. And then what we want to do is set the shot. So we'll take our value param and we'll set the value of that to our shot 0. And then we'll just print our shot for now. And finally, we'll set the value param back to our current shot 0. Okay, so let's run that. There you go. So we have our list of shots. So we'll be setting it on here and then going back to shot 30 by 10:30 when we're finished. So now instead of printing the shot as we cycle through, what we want to do is cook our node and then find the locations under root world geo. And to do that, we're going to use producer. So we'll say our root producer is equal to, and we're going to use the nodes 3D API and get geometry producer using our node. So you've got geometry producers and render producers. The geometry producer will just give you the state as it is in now, so how the scene graph is right now. And then you've got render producers, which will be what will be sent to the renderer, so that will apply all of the deferred operations, etc., all your implicit resolvers. Okay, so we've got our root producer, and then we want to go from our root producer to our geometry location, so we'll call that a geometry producer or geo producer, and we'll take root producer and we'll get a producer by path, and we'll call that root location, and we'll create a new variable here. Say root location is equal to root world geo. And now we need to get the potential children, and when you get the potential children, it will return an attribute. So we'll say locations attribute is equal to, and we'll take our geo producer and we'll get potential children. From this locations attribute, we want to actually get the locations. So we'll say new locations is equal to, and we'll take our locations attribute and we'll get nearest sample, and we'll turn that into a list. And now what we want to do is start off with an empty locations list. And as we cycle through the shots, if this location isn't already in our locations list, then we'll add it. So to do that, we're going to cycle through using, so we'll have our locations and we'll do an extend, and then we'll do a X for X in new locations if X not in locations. So if X is not in our locations, then extend our list of locations with this new list. Okay. So now we've finished that, we can take our locations and sort it, and then print the result. So let's run that. And you can see we've got env house, cam, char avo, char jow, char may. And now what we'll do is we'll write the code to create all of the nodes that is using this information. Now, before we create any new nodes, what we need to do is remove any connecting nodes currently connected to our PassBuilder node here. So let's remove our print locations. We'll say if locations, then connected nodes equals, and we'll use the node graph API, and we'll say util get all connected outputs, and this needs a list of nodes, but we just want to check our node. And then what we could do is cycle through this list and then just delete every node that we find. But we also want to find the backdrop node that is associated to any of these nodes. Now, there isn't a function built into Katana for finding the backdrop node of a node, but there is a function that was posted on the forum, and I'm going to use that one. So I'm just going to copy and paste that straight in here. I just go right to the top and stick this in here. So let's expand this out, have a look at it. So it's get container backdrop nodes for a node that you give. And it's going to use the node graph tab to send hits from the boundary of the node and find out what else is available, and then check what type of node it is, and if it is a backdrop node, then use that. This is all commented, and you'll have the code from this tutorial, so you can have a look more into it, or you can find it on the forum as well. Okay, so what we want to do is go through our nodes for n in connected nodes, and backdrops equals, so get container backdrop nodes for our n, and so we'll say for backdrop in backdrops do backdrop dot delete. And then after we've deleted the backdrops, we can then delete our node. So let's give that a run. And now we don't have anything underneath this. It's removed all of our nodes, and it's also removed the backdrops. Perfect. Let's now set up some variables. So we're going to go up to the top here, and we need X spacing is equal to 500, Y spacing is equal to minus 200. This will be so we can position our nodes. We'll have a dots to connect, which will be an empty list where we can add all the dots that we make to this list to connect them later. We'll have a position of our node, the node graph API, get node position of our original node, and we'll turn that from a tuple to a list, so then we can change the values of our position. We'll do that now. We'll say pos plus equals, pos1, sorry, plus equals Y spacing. So just move it down the Y spacing, so on minus 200 from this original position of the node. We also want to set the parent to be node get parent. So any new nodes that we make will be in the same area as the original node. Next, we'll also add in a function we've used before in previous tutorials for connecting our nodes. So a function here, and you give it a list of nodes, and it will cycle through those nodes, take the output port of the first one and connect it to the input port of the second one, and that's it. So let's go back down here to where we were before. We've deleted all our nodes. Next, we want to create a invisible node. So POS invis node, and that's going to be node graph API create node, and the type will be a PRMan object statement. The parent will be the parent. Okay. We'll take the POS invis node and we'll set the name. We'll say POS or geo camera invisible. And the POS invis node will get parameter of the cell statement, and we'll set the value of that to be our root location times 0. Next, we'll need to get the camera param, and that what we call POS invis node get parameter PRMan statements attribute visibility camera. And then for the camera param, to get the child param of enable and set the value of that to be 1. So we'll turn it into a local parameter, and we'll then get the child of its value and set the value of that to be off. So nothing will be visible to camera, and then for each of our render nodes we'll set the visibility to be on for that location. Next, we need to position this guy, so node graph API set node position, and we'll give it on POS invis node, and we'll give it the tuple of our position. And now let's connect them. So we'll connect nodes, and we'll give it the node, so our original node, and maybe get POS invis node connected together. And now what we'll do is just move our spacing down. So we'll create a node underneath here, and then we want to get ready for our next lot of nodes. So we'll say POS 1 plus equals Y spacing again. Now what we'll do is enumerate over our locations. So we'll say for I location in enumerate locations, and we'll start our enumerator at 1. We'll need a couple of empty lists, so we'll need a nodes to connect list, that will be empty, and we'll also need a nodes to backdrop list, that will be empty. So as we create these nodes, we can add them to the list, and at the end we can then either connect them all together or set a backdrop for all of them. We'll take our location and we'll split it. So we'll say location split is equal to location dot split by an underscore. We'll say if the length of this location is greater than 1, then we'll continue. The reason we'll do that is just to differentiate between the camera one and all the others. So All these others have an underscore and the camera doesn't, so I'll ignore that one. Okay, so we'll make a dot node first, and that will be node graph API create node. And the type of this one will be dot, and parent again. We'll set the position, set node position, and that will be the dot node, and again we'll tuple that pos. We'll append our nodes to connect with our lovely dot node. And dots to connect. We'll also append dot node. Going to create a few more nodes as well, and it's a bit repetitive, so I'm just going to copy and paste this in here. And let's just clean this up. Move these back one. So after our dot node, we're going to create a variable set node to the parent. We'll give its name as vs underscore location. We'll get the parameter or variable name, and we'll set the value of that to be pass, and then we'll set the value of that to be our location. So then we can use variable switches, variable enabled groups, etc. further up in our template to turn things on specifically for our different render nodes. Next, we'll set the position, so we'll just use the Y spacing again, and then we'll add this node to our nodes to connect and nodes to backdrop. Then we'll make a PRMan object statements node to the parent, and we'll say POS underscore location for the name. We'll set the self statement to be our root location plus the current location. And we'll set the camera visibility of this one, so we'll enable it and set it to be on. So this location will now be visible to camera, whereas everything else won't be. And we'll set this node position to be the next one underneath, so we'll take the Y spacing and multiply it by 2, and we'll append those. And then after that, we'll make a render node, and we'll set the pass name to be the value of the location. And when you set the pass name to be a value, it will also name the node the same thing. And then we'll set that node position again, so we'll move down one more, so times it by 3. And lastly, I'm going to set the draw outputs attribute of the render node to be false, so I don't want all of those little triangles at the bottom of my render nodes. If you've got lots of outputs, it just gets really massive. This keeps it nice and clean. And we'll again set the render node to be appended to the nodes to connect and backdrop. Now we'll have all of our nodes to connect. We can connect our nodes. So connect nodes, and it will be our nodes to connect. We need to do a backdrop node. So BD node equals node graph API create node of type backdrop. It's a capital B. And again, the parent node will be the parent. I need to set some attributes on that backdrop node, and I'm just going to copy and paste that as well and walk you through it. So we'll take the text as an underscore to start off with, and then we'll take the I value, so the enumerated value, and pad it with zeros. So it will be 001, 002, and the underscore will just mean that when we hit J for our list, it will be at the bottom, and then because we have the number 0, 1, 2, 3, it will be in order. So we'll have all of our render nodes in our bookmark J, so we can jump to them easy peasy. We'll set all of them to be a red color with a font scale of 2, and we don't want to hide it as a bookmark. We want it to appear when you hit J, and we'll send it to the back. So we have all of our attributes. We need to apply those attributes to our backdrop. So we'll say node graph API, and we'll set node shape attributes, And we'll give it our BD node that we've made and our new backdrop attributes. Now next what we want to do is set the backdrop node so it fits around the nodes that we've created. But when you make the backdrop node, you then need to process it in the node graph, so then it can be using the fit backdrop nodes and the drawing module. So to do that, we need to use utils event module process events. So we'll make sure that we can now use the drawing module and fit backdrop node around nodes. Now, it's quite important to know about processing events before you can do some things. That has tripped me up quite a few times in the past. And we'll give it a padding of 75. And then we would want to move our X position over for the next lot of nodes. And now we get out of our loop and we'll connect all of our dots. Finally, we need to connect our POS in Viz node to our first dot, so dots to connect. First one, and that's it. So let's come off here, give this a run. Port 99, what have I done wrong there? Let's have a quick look. PRman statements, attributes, visibility camera. Let's give that a go now. There we go, starting to make some stuffs. 155. Let's just delete this. Delete this as well. 155. Okay, and then connect, not connected nodes, connect nodes. Let's run that. And there we go. That looks like I accidentally created a node one time already and I messed up the code. Try running that again. There we go. So we've got our POS all geo camera invisible, and we have each of our render passes. Now lastly, what we want to do is have it so that if there is a live group of one of these, then it will load that instead. So to do that, what we're going to do is at the top here, we're going to have another variable, and we're going to call this live group location. I'm going to set that to be a user directory, documents, Katana, render passes. And then in this folder, I have a live group for char jow. So what we'd want to do is see if char_jow.livegroup exists in this folder, and if it does, load the live group instead of creating the render passes. So let's do that. Go back down here. And where we've got our dots to connect, here we'll have LG path is equal to, we'll take our live group location and we'll add slash, and we'll have our current location, and we'll add a dot live group. what we'll say is if os.path exists of our lovely LG path, then what we'll do is we'll do something else. We'll create all these other nodes. So we want to move these out. Up to our render node. So they're now going to be run if there isn't LiveGroup. And we'll say print has a LiveGroup associated with it loading. We'll add in our location. Now to load our LiveGroup, we're going to have a LiveGroup node, which is going to be equal to node graph API create a node of type LiveGroup. Again, attach it to the parent. We'll set the name to be LG, add location to it, set the position, LG node, and we'll give it a tuple, and we'll give it pos 0 and pos 1 plus y spacing. We'll do our LG node set source as our LG path. And we'll want to reload from source. And this will force it to load in. If we don't do this, it won't load in the LiveGroup and then have the input node for us to then attach. And now we can do nodes to connect again. And add our lovely LG node. And nodes to backdrop. We'll append LG node as well. Okay, and that should be it. So let's give this a run. Oh, the syntax error at 119. Gonna close that. Let's try that guy. 121. Oh, added square bracket there. There we go. Okay, 121 again. 121. Me being silly. Did want a square bracket there. I didn't put a square bracket at the start. Okay. There we go. Now we've got it. So it's loading the LiveGroup. And there we have it. We have all of our lovely render nodes and everything is working. Brilliant. So let's now make the PassBuilder node. So if we go up to where we set node equals, we can now comment this out. And let's select all of our code and copy it. And now before our PassBuilder node, we're going to add in a dot node. Select the dot node and hit G to turn into a group. And then we're going to edit user parameters and add in a button. And then in the widget options, we're going to paste our code and we'll set this to be called build. Okay. And then we'll toggle LiveGroup appearance so it looks like a regular node and show user parameters at top level. Finish that. And then let's delete all of these nodes. These ones. And let's rename this as PassBuilder. There you go. So we've now got our node, and then we can save as macro, PassBuilder, accept. And then now we have it as part of our menu, and we can add it in. Job done.